This is the second video in a sequence of 3 videos on decorators in Python. In the first video we looked at the namespace, and in this video we're going to look at how functions are first-class objects in Python. So what that means is that functions, first of all, actually are objects, and second of all, they're first-class objects in the sense that you can use functions as you would any other kind of object. It's not true in all languages. In some languages, functions have different ways of being treated than a regular variable, but that's not true in Python. In Python, you can treat a function as an object, and you can treat it as any other object. So we're going to see that through some examples here. And a lot of these ideas, I mean, you can find these on the internet. One interesting source to go to is the BDFL's blog, The Benevolent Dictator for Life. The BDFL is Guido von Rossum, who invented the Python language and still is basically in charge of how the language develops. So ultimately, any decisions about the Python language come back to Guido and his decisions. Okay, so here's an example. We have a function 1 that doubles a variable, an input, and we have another function 2 that's kind of interesting. It takes a parameter f and a parameter z and returns f of z times z. So the implicit assumption here is that this first parameter f is going to be a function. So we can pass in functions as parameters and then use them as such. And then if I run this, I'm calling function 1 with 3, which should give us 6. And then I'm calling function 2 with function 1 with the value z equals 3. So what we should get here is function 1, that's f, function 1 of z, z is 3, that's the second parameter, right? So function 1 of 3 we know is 6, and then we're going to multiply that by z, which is 3, and 6 times 3 is 18. So you can pass functions as parameters to other functions and use them inside the second function. So here's an example of how you can functions as objects are treated as any other variable. Okay, so here's a second example. Functions can be returned. So I have an outside function which is going to take a parameter x, and then we have an inside function, two inside functions, inside 1 of x and inside 2 of x. And inside 1 returns x squared. Remember that in Python, when you want to raise a variable to an exponent, you use the double star notation. And function 2 is going to multiply that x by 2. And then we're going to determine which one of these functions we're going to return. So this is the modulus operation. We're dividing x by 2 and checking the remainder. And if the remainder is 0, in other words, if x is even, we're returning the function inside 1. And if x is odd, then we're returning the function inside 2. Alright, so we're going to run outside function. We're going to pass it a parameter of 2, which should return inside function 1. Then we're going to treat that as a function. So we're going to pass the parameter 2, which should return inside 1, which is a function. And then that function we can pass a parameter 3 to. So we're going to pass it the variable x. And then outside function we're going to run with 3, which should give us inside 2. And then we're going to pass that a variable 5. Notice that the x's here are being treated differently. So I have a 2 here for this x, but then I have a 3 here for this x. And using the scope of these variables, this x is this x here, but once you go inside of inside 1, using the namespace or the scope of these variables, this x here refers to this x. So what happens if we run this? So we print outside function 2, which is a function inside 1 of x, and we get outside function dot locals. So this is inside 1 is a local variable inside 1. So that's the function inside 1. Now we pass in 2 and 3. So again, because this is 2, the remainder should be 0 for this x. So 2, sorry, be a little more clear. This 2 is this x, and inside of this function we go here, we divide 2 by 2, take the remainder, we get 0. So return the function inside 1. So this is now the function inside 1. We're going to pass to it the parameter 3, so that becomes this x. See, it's complaining about shadowing name. I should have named this x differently from that one, but I didn't have to. And we pass in 3 for this x. This becomes 3 squared, and we should get 9 as an output. So we get that. And then here we have outside function 3. 3 divided by 2, take the remainder as 1. So we get the inside function 2. And we pass the parameter 5 in for x, and 2 times 5 is 10. So the whole point of this example is that you can also return functions. So you can pass functions in as parameters, you can return functions. And again, the idea is that functions are first-class objects. They can be treated as any other object. Okay, using Python you can do something called currying. Because these are first-class objects, you can define a function that's supposed to take 2 variables and define them separately as functions of 1 variable each. So there's a whole topic on currying. It's an important topic in theoretical computer science. It can lead to more efficient programming. This is not a topic we're going to explore deeply. In fact, this is going to be it. But if you wanted to, you could look up currying and learn more about it. So here's how this works. I'm going to define 2 different area functions, and they're going to do exactly the same thing. This one is probably the more common, what you would, if I asked you to write an area function given a width and height, find an area of a rectangle, then this is probably what you would do. You would say, oh, length, width, x times y is the area, and be done. But there is another way you can do this. I can write a function of 1 variable and then return compute, where compute is defined inside of area, and compute takes another parameter y and returns x times y. And there's something interesting going on here that we'll have to talk about in the next example. But if you run area 1 and pass it 2, then you get back a function compute y. Now, this variable right here was passed to x. Then we're going to pass 3 into y. So area 2, this right here, this whole piece, is now compute y, right? We return compute. So we're returning this compute function. We pass that the parameter 3, so now y is 3, and then this should print x times y, or 2 times 3, which is 6. I'm going to talk about this a little bit more here in a second, but area 2 is much simpler. We just pass in 2 and 3 as variables, missing a white space, and the, x becomes 2, y becomes 3, or return the product, and we're done. So there's different ways of presenting a function of 2 variables. One is you just have the parameters in a comma separated list, and then in area 1, the curried version, we have them variable separated, and we're passing a parameter to a parameter, sort of. Let's run this, and we get 6 in both cases. There's something a little bit funny that happens here. So we pass in, well, let's take a look at first class objects 4. Well, there's something similar in first class objects 4, and we'll come back and look at the other one. So in this example, I want to talk about closures, and then we'll go back and talk about first class objects 3 again, that example. So I've defined a circle function, and inside of circle I've defined a constant. So this is one way you could go about defining a constant, I guess. And then inside of circle I've defined a function 2, which returns pi times x squared, or the area of a circle. So this returns that function 2. So I'm going to define area to be circle. Notice I put the parentheses on the end of this. So area is the circle function. then area gets returned to it a function. So I can pass in parameters to area. So if I can pass in 4. And if I pass in 4, then I get the area of a circle with radius 4, which is 50 point blah blah blah. If I pass in 1, I get the value for pi, at least out a few decimal places. So what's curious about this, and what is this closure business? Well, the curious bit is when you define area as circle 1, you execute this function, and pi is declared, and then you return function 2, which gives you this function right here. But pi is declared inside of circle, so once this function circle has executed and has completed execution here, then pi should no longer exist. That namespace no longer exists. So how is it then area is able to compute pi? Well, it's something called a closure. And this is going to get into more theory than perhaps we want to, but the idea with Python and in creating these first-class objects, so this function is a first-class object and should be able to be handled like any other first-class object. Since we're returning this value, in returning this function as a value, because it's a first-class object, we should be able to use it out here since we've returned it. So Python creates what's known as a closure. So not only does it return this function, but it also returns any variables inside of def circle that it needs to know. So it provides more information than just func2. Now, how much should you take out of this? Well, again, closures is another topic that we could spend a lot of time on, but we're not going to. If you want to read about them, you can. It's an interesting topic. But the idea here is that you can define pi, and function 2 will go ahead and remember it. This actually comes back and relates to something we had here, because in this area function, area 1, we passed in a parameter x. This variable x is now local to, or in this namespace inside of area 1. So compute has access to that variable x. But here's the interesting bit. Once you've executed area 1, so we passed in the parameter 2, and this calls area 1 and runs that function. Once that function has been run and returns compute, this x should no longer exist. That should disappear. That was local to this function. When the function is done executing, all its local variables go away. And yet, compute, which was returned, is able to remember x times y and compute 6. Again, it comes back to this idea of closure, that when we return compute, Python knows that, oh, compute needs to know this value of x. So I'm going to return all the information about compute as a function, but not only the information about compute as a function, I'm going to return any information that compute needs to operate as a function so that it can do the operations that it needs to. In other words, I can return compute as a function and it will function just fine. And that's what it means to be a first-class object, that it will behave as you would expect it to if it was any other variable. And we would expect if we returned a variable, then we should be able to use it. And in order to use compute, it needs to know x. So Python ensures that it does. So that's called the closure. All right, so first-class objects, in summary, means that any function or we've also used the term procedure. Procedures or functions in Python are objects, and you can treat them like any other variable. You can return them. You don't have to worry about what kinds of variables you've declared and it's using. If you return the function, because it's returned with a closure, it will behave just fine. And you can also pass them in as parameters to other functions, and they will behave just fine. They'll behave just like you expect them to. And that is the Pythonic way.